Hello. Ooh. Good afternoon, everybody. Clearly they keep giving me a mic and it keeps being a mistake, but I am very excited for our next speaker here at the Emerging Technologies Caucus Crisis Technology Center. So this is part of our Micro Talk series, and today we have, for the afternoon break, Eric Kant, who's going to be talking to us about everyone's favorite topic, drones, or if we're being a little more technical, UAVs. So please come join us over here at the Crisis Technology Center. We're right at the front of the expo, near where the auctions are, and learn a little bit more about some of the technology that's emerging. Eric, take it away.
Thank you. Thank you so much for having me and letting me speak today about UAVs. Closer to my mouth, please. That high? Okay. Give me 1 second while we figure out how the presentation works. I know you made me use Prezi, and now I don't know how to make it go back and forth. Oh, come on now. We need a short technical pause. Tell some jokes.
Do you want me to fix it, or do you want
Nope,
to fix it?
I got it.
Do you know? Yes.
I do. So I'd like to talk about unmanned aerial vehicles, but more so, as you will see, I'd like to talk about the sensor and its integration into your overall command and control operations. I know everyone today sees the UAVs, they see how inexpensive they are, they see that you can purchase them readily, people are flying them all over the place, but are they necessarily appropriate for emergency management operations? Definitely not the UAVs that you use in the model scope. So UAVs around the DJI type or those type of equipment is perfect for the hobbyist and for some businesses, but we have to understand working in a public safety venue is very different than doing photography for a realtor. So what do you need to know before you fly? You need a COA, a Certificate of Authorization, from the FAA to be able to fly any UAV as a public safety entity. Is anyone going through the COA process by any chance? You are? And for smaller drones, the quadcopter types?
Yeah, we're looking at quadcopter
and fixed wing. And I know Spencer Hawkins in the background there from Georgia is also going through the COA process. We talked about that yesterday quite a bit. And I'd like to talk a little bit about that process and who can obtain a COA. I will also highlight the devices. This is actually a Trimble Gatewing, which is a very nice device for doing mapping, and we've all heard of the Trimble company. They do a very nice UAV. I'd like you to notice here who can get a COA. I'm not going to read through the slides, but more importantly, the notice that you cannot, as a public safety entity, utilize the model aircraft operating standards for public safety work. You must obtain a COA, you must have approval through FAA, and that is very mission specific. And we'll start to go through that, as I'm sure you're learning. I worked on a committee with NJIT where we actually obtained a COA 2 years ago to fly larger UAVs, Coast Guard sized devices. Don't ask me the exact device name or model number, I do forget that. But we augmented that UAV with LTE transmitters to be able to flood an area with broadband connectivity, and tested that in the actual national airspace down in Cape May this last year in New Jersey. What you see here on the left is actually the document that you will fill out for your COA. And I'd like you to notice not only is it hyper complex to fill this out, but it is very detailed. They want to know exactly what the mission parameters are, when you're going to fly, how you're going to fly. And one of the elements here to keep in mind is that the COA is really about your ConOps, right? It's about how you're going to put this together, how are you going to notify the FAA that you're going to fly. So we worked with the team up at North Dakota who had one of the first small UAVs with the Sheriff's Department up there. They require 3 people to be on scene to fly the UAV, as well as a 45-minute lead time because they have to notify the FAA to close down the airspace. These are not devices that you're going to be showing up on scene, popping them out of your trunk and throwing them up in the air. The FAA, one of the projects we worked on with ODNI and DHS-INA was a UAV research project. I've got that on my blog, and you will be able to find it at the end of this presentation. A lot of people feel the FAA and this process is too difficult, time-consuming. The one thing that I learned in working with the FAA is that their only concern is safety of these devices while working in the national airspace. So this ConOps development, your mission parameters, your mission scopes, this all relates around appropriate safety to be able to have these devices. And I have my own UAV that we fly as a family, and what I learned very early on is that they are dangerous. The radios get interfered with on a regular basis, especially if you're using the hobby models, the DJIs and the rest. A strong wind, even though they are very stable and work well, a strong wind can take that UAV and blow it into a highway very easily. And they become a flying object and become very dangerous when you're trying to use them. I'm also not a big fan of just video. So if you want to fly UAVs and you want to implement this into your concept of operations, my recommendation is to find the appropriate sensor first. Decide what you want this UAV to do. What is your concept of operations, and how do you want to apply that to your working environment? You will have to do that anyway to obtain your COA. You will have to detail all of your mission parameters for the FAA in advance. And just recently here talking to Spencer, they submitted their first COA, and now we're going through the secondary phases where the FAA has changed their mission parameters to some aspect. Often they are requiring now that you have to have a pilot on the team, as well as 2 or 3 other people, a mission specialist, a sensor specialist, a safety person. How many people did you guys have on your COA team? Oh, so you have 3, a pilot, a safety specialist, and both. And has the FAA approved that already? It's going in next week, so they may or may not approve it. Your ConOps, of course, will define the drone, the sensor package, and then more importantly, how does this interoperate or integrate into your command and control facilities? So you heard me mention that I'm not a big fan of video, and why is that? Somebody has to watch it. Somebody has to watch it, they have to interpret it, they have to do something with it. Once your agency knows you have a drone and you're producing video, they're going to want access to the video. What do you do with it? How do you upload it? How do you handle privacy concerns? There's a lot of aspects around this, much less now when you get into the actual flying. So for me, being a boutique integrator, it's all about the sensor. You really have to decide what is the sensor package, how does that sensor package work in your integrated command and control, and then you can decide on the appropriate drone. So for the little guys, the micro drones you see everyone flying today, that's pretty much limited to video right now because a lot of the sensors are just too big for those kind of devices. Just at a trade show a few months ago I was at, they had actually a quadcopter with LiDAR on it, and the thing was 5 feet wide. With an electric motor on it, no less. It was a monster device, but to get LiDAR on a quadcopter, that's what they needed to do. And you see some of the examples here in the slide of LiDAR, infrared, and then more importantly, an integrated solution into your overall command and control. So when you think of these, you have options. hyperspectral imaging, synthetic aperture radar. And how are these used? So SAR is used in North Dakota for ice jams. And I'll show you the device that they use to film these. But you can see here what's nice about SAR is not only do you have a picture, but every pixel has data underneath it. So you can actually do analytics with this device. You can actually understand the changes in the ice flows between water and ice, and then layer them over each other to see the changes day by day. And then LiDAR, infrared imaging. Obviously, I'm not mentioning all of the sensor packages that you might implement on one of these devices, but giving you a little bit of an example of what to consider while you're putting these together. Although this is not a LiDAR picture that encompasses, that came from a drone, I thought everyone would appreciate the LiDAR, and if you recognize the location, you can see how far back we've been doing this kind of work. Manned aircraft, unmanned aircraft, the only difference is really cost, not if you need 4 people to run it, but is cost, and also the mission parameters. So when you're looking at these sensor packages and you look at these multiple devices, what we have here is, of course, what the North Dakota Sheriff's Department up there, I forget the name of the actual agency, is running. In the upper right-hand corner is what they used for that ice jam imagery. This is a Global Hawk, which is the U-2 replacement, which is also a fully automated drone. And in the lower right-hand corner there, the team I was with up there in North Dakota for that research project, and a CBP Predator. Currently, from my understanding, CBP is the only organization that has a standing drone COA that they can utilize in the national airspace. We were also briefed by the North Dakota State Emergency Management that they borrow that quite often. So you may not need your own drone, you just need the guy to call up and ask for the one you want. And no reason not to. That doesn't mean they won't send you a bill at the end of the day. So what are the challenges around this? And this is a very interesting read because I pull these challenges from the Department of Defense Unmanned Vehicle Roadmap up to 2025, I believe was the document here. And I call to the top 2 components. Number 1 is the interoperability of the sensor and the sensor data into your overall command and control. The video, what are you going to do with it? Who's going to read it? Who's going to process it? Etc. and so forth. You sort of get the idea. The one that I find most interesting and the one that is most limiting, at least from my aspect in our space, is autonomy. And that really is going to be a requirement because who has 4 people in their agency or 3 people in their agency to split off and run drones for you? Think about that. What if you've now got 3 different drones? That means you need 9 people to run your operation. It is currently, and this is also a problem for the Department of Defense, a Predator team is a large team. And one of the interesting things about the Predators is that they don't land and take off autonomously. So somebody has to land them and take them off manually, and then it is taken over by autonomous control. The reason for that is, if anyone is interested, is the satellite uplinks are too long of a delay to be able to land and take off. The Global Hawk is fully autonomous, and that does land and take off by itself. So interoperability, when you decide on a sensor package, if it's synthetic aperture radar, LiDAR, any of those capabilities, how do you now get that into your command and control, how it is interpreted, and autonomy. DARPA this last year put out a program looking for drone autonomy, much like the DARPA challenge for vehicles. You will continue to see this run massively ahead because of Amazon and the other aspects. That all needs to be autonomous. There's no way Amazon's going to replace a delivery guy with 3 people to fly a drone. It's just not going to happen. And if you're interested, the lower right-hand corner is a Predator control bay. In the middle here is infrared used for precision agriculture. And really, a good example of where this is going to go is the precision agriculture organizations that are now using drones, but more importantly, they're using multiple drones. So we saw an example in a white paper out of Japan where they're using stuff like the gate wing and the fixed wings to do flyovers with infrared. They track what plants are too dry. They automatically talk down to a control base that then sends out a quadcopter with exactly what that plant needs. They water the plant, fungicide it, it goes back. The whole thing is automated. They've got their stuff together, right? Also, it's usually in a farm where flying these things are not as dangerous. Additional considerations. So it is not just about the flight, right? And when we look at this, there are a lot of additional considerations. Pre-mission planning. Have you thought about a range? Where are you going to practice? How are you going to practice? Right? You can't just say, hey guys, now you got a drone, let's go fly it, right? We all work in the business. You got to put together the ConOps, the plan. You're going to have to test your people, evaluate them, exercise it on a regular basis. And when we're talking about these smaller devices, especially the hobby devices, what I would recommend is you look at those devices and understand the mean time to failure for your electronic components or your mechanical components. That's what you usually don't get with the smaller, cheaper devices. How long will that motor last? Every flight needs to be recorded. If your motor is only good for 100 hours and you've got 70 hours in, you replace those things prior to them becoming a problem, just like a standard aircraft implementation. And then, of course, mission support, both post-mission analysis, where does this go, how do we handle it, what do we do with it, and those kind of capabilities. Obviously, this is not going away. People see it in the news. They want them. Your politicians may want them because they see people using them. People think it will bring economic wealth into communities. Look at the numbers that we're talking about here. They are not going away. They are a phenomenal tool if you're willing to put the effort and energy in to utilize them and understand their limitations. And thank you. That was my UAV presentation, and if anyone has any questions, I'm more than happy to try and answer them.
Do we have any questions?
Well, thank you. If anyone has any questions.
Yeah. Any questions? Go ahead. I'm going to repeat it so the Periscope can hear it. Is there a list of different sensors that can go on homemade UAVs?
Yeah, there's actually a great list, and now that you've asked me, I can't remember the gentleman's name, but if you remind me, I can dig it up and either post it or send it to you. There's a gentleman who publishes regularly. He's a doctor who works with UAVs in humanitarian aid. Patrick Meyer. That's exactly it. He not only publishes all of his works, but he has some great spreadsheets and other online resources that list out hundreds of sensors, the devices that they're appropriate for, and they are using it on a near-time regular basis to map refugee camps and all sorts of components. The really nice work, the really nice thing about the work that Patrick is doing is that he publishes it all onto the web. and makes it all available. And it's a great resource to understand not only the sensors, he also publishes great works about ConOps, integrating those ConOps into your environment, and also drone command and control software. There are a number of open source software suites that allow you to automate your drones. I know my DJI now comes with full automation where I can go into the phone app, tell it what I want it to do, how long I want it to be on station, and hit play, and the drone just goes off on its own and does its thing. And that's the autonomy that we're going to need to see. You know, when these really become effective, one of the nice use cases a friend of mine came up with, he works alpine ski patrol. And a drone would be a great solution to find that skier and identify him. More importantly, the big problem with ski patrol is getting back up. If they pass the skier, it's a real problem, right? The drone would come up, identify the skier, and allow you to be guided in directly to the person to be rescued. But that won't work if you have to get a person up there and fly it. It may not be line of sight over the mountains. You really need autonomy. The call comes in, the drone pops up, it goes down the ski slope, finds that heat signature, guides in the responder. That's a ConOps that works. Peeling 3 people off to go fly a drone to find this guy to get the responder there doesn't work. And that's really why it's all about the concept of operations and the sensor. What do you really want to do with it?
Our next question is, does a recreational drone user need to have any kind of licensing?
From what I understand, currently they do not. Is there a state of Ohio regulation on that? That's interesting. So some states are mandating some type of certificate. Listen, I'm not going to comment on policies and procedures. I can tell you the gentleman who ran our research project was the Director of Intelligence for the FAA. And it was enlightening to talk to him because we had a drone. I'm a fireman. Hey, I can do this. The kids can do this. This is a great tool. Let's use it. Starting to talk to the gentleman at the FAA, when you start thinking about all of the things that can happen with something that is flying in the air, we as public safety professionals need to take safety first, right? So flying a drone because it's cool should not endanger our own responders or the public, right? So you really have to decide what you want and how you want to do it. And to be quite honest, is that quadcopter that you have to fly really the right solution? I'll tell you, that Trimble Gatewing, you throw that thing up in the air and it just goes back and forth and scans the area and gives you your data. Quadcopters, you actually have to fly them. And granted, they are very easy to fly. Somebody still has to fly them and pay attention. Actually, no. Dropping anything from an aircraft is completely against FAA regulations, period. And that's why they have a big consternation with these people who've been putting guns on drones, because that's actually dropping something off of an aircraft. I don't know, that's a little too specific. Put in your COA and see if it gets approved. Yeah, absolutely. The COA process is pretty much the same for, so that same COA list that you saw me put up there, the list of items, and you can actually go to their webpage. They've got frequently asked questions. Know Before You Fly is a great resource put up by the FAA and I want to say the Model Association that talks about exactly how, if you're a commercial entity, a public safety entity, and the process to go through to fill in that paperwork. I would also, if you are interested in it, Spencer is over there at that table in the corner. The gentleman here said he's going through the COA process. No need to reinvent the wheel. right? Talk to your friends, talk to the other agencies that are doing this, and learn what has worked and what hasn't worked. And don't expect it to change, or expect it to change. Right? The FAA is working through this, and they want it to be safe for everybody. That's something I can definitely get behind, that I didn't necessarily understand as just a hobby flyer. So I think we can all agree it's a nice toy, but you want to have safe operations all the way around. More importantly, you want it to augment and help your operation. You know, more times than not, we see a nice shiny widget. We want that technology, whether it's really going to help or not, just because we want it. Drone is that next shiny widget.
I just want to point out the site that Patrick has put together. The organization is uaviators.org.
uaviators, yes, thank you. uaviators.org, yes, thank you.
Code of conducts on there that are written to be used for humanitarian missions. There are all the curation of legal issues for many nations.
That's right. Yeah, it's a phenomenal resource, and what's the nice thing is that Patrick has been able to implement this and use this in areas where there is probably no regulation at all. Nobody to care about what they're doing. But it has been a very interesting read to see them go through, and what they've learned are some really great lessons learned that apply to really any operation with these devices. Thank you.
Another point on the flight certificates. So I'm David Black. I sit on a advisory committee in Canada, advising Transport Canada on use of. I sit on a working committee for emergency management and first responders, advising Transport Canada on regulations, use of drones. And in terms of some advice I could give you when you're looking to get your first flight certificate, apply for something that's fairly simple and not very complicated, because I'm assuming that the FAA is taking the same approach where they want to get to know you and trust you that you're a good pilot, and so you're much more likely to get approval for a certificate if, for example, the first thing you ask to do is to go out in the middle of nowhere and do some training, as opposed to, right away I want to do, fly drones over an accident scene and do photogrammetry, this sort of thing. Yeah, that's the points I had to make.
Thank you, Dave. I appreciate that.
I need to close this off, so you good?
Yeah, I'm good. Thank you.
So thank you so much for joining us today. We were really happy to have Eric joining us, and thank you all for attending. I want to tell you a few follow-up pieces of information. We are going to be having a webinar on this topic either in December or January. It will be distributed out through the IAEM listserv, so you'll get it from your regional president. It'll be posted everywhere. But the Emerging Technologies Caucus is not just social media. We are interested in all emerging technologies, and so we're trying to bring in some of that information. So continue to follow up. Thing number 2 is that we are doing video testimonials for the IAEM conference. Right back there, the guy in the red shirt is ready to take your video right now about how much fun you're having. So go ahead and say hi to him. I know, I saw the excitement. You're all going to rush there as soon as I let you go. Number 3 is the fact that we are going to have our Emerging Technologies Caucus meeting during the next session. So we're right across the way. If you would like to join us, please feel free. You do not need to be a member to come to the meeting. So feel free to stop in and join us. And then our next micro talk, and yet again, I'm not going to remember the topic of our next micro talk. I believe it is Sarah Miller, who is going to be talking about deploying and the technology you want to have in your kit. Have you actually thought about that? When's the last time you had to do a response? Do you have a list? Do you know what you want? So she's going to be talking about that during the evening break. And finally, if you want to hang out with us tonight, because we're a cool bunch of people, meet here at 6:30 and we'll figure out where we're going. So thank you all. Have a wonderful rest of your afternoon.